Afternoon class. So we will continue our discussion on limits. We have finished limits, or rather infinite limit. What is an infinite limit again? A limit, of course, but one in which what? Limit in which message into the chat box. And here in my other gadget. Okay, let me see. Values are not finite. Values are correct. An indeterminate form, on the other hand, is a kind of a limit which yields 0 over 0, which may or may not exist. Now we have another type of limit, which is a limit at infinity, or limits at infinity. And from the phrase, the way the phrase is constructed, it is a kind of limit that is taken at infinite values of x. Although technically, infinity is not a number. But what we mean is that the x values are getting larger and larger, either positively larger or negatively larger. So let's take an illustration here. Consider the limit there of 5 over x cubed, and without showing you a table of values, you may verify this, but it is not hard to see that as x gets larger and larger positively, this one will get smaller and smaller, so that in the limit it is 0. For example, if x is 10, then this will become 5 over 1,000, and 5 over 1,000 is already very small, 0.005. Now you increase that by a factor of 10. Then if you increase x by a factor of 10, then this one will get smaller by a factor of 1,000. So for example, if I plug in 100 for x, this will become 5 over 100 cubed. What is 100 cubed? That's already 1 million. 5 divided by 1 million is very, very, very small. And so on. Now we say that the limit as x approaches infinity, so this is a limit at infinity, x is approaching infinity. Okay, again, limit as x approaches infinity of 5 over x cubed is 0. Similarly, we can also conclude that the same function has the same limit as x approaches negative infinity. So this is another kind of a limit at infinity. So it could be either positive or negative infinity. But though this is negative infinity, still you are dividing by a very, very large number negatively. However, it will still approach 0 from the other side, so the limit is still 0. So take, for instance, negative 100. If you plug in negative 100 and you cube negative 100, that will become negative 1 million. 5 divided by negative 1 million is like negative 0.000005. And you do it for x equals negative 1,000, then it becomes very, very small negative. So that in the limit, it's still 0. So you see that for limits at infinity, the limit may not necessarily be infinite. The limit may be finite. Unlike for infinite limits, when you say infinite limit, the limit actually is infinite. could be negative infinity, could be positive infinity. But for limits at infinity, again, you're approaching infinity for x or negative infinity. But limits at infinity may be finite. And as we shall see later on, limits at infinity can also be infinite. So a limit at infinity can be an infinite limit. So please don't confuse the two types of limits. Now, let me give you an example of that. A limit at infinity, which is infinite. Consider the polynomial 5x cubed. Let's find the limit of that as x approaches negative infinity. And it is not hard to see that when you cube a very large number, okay, negatively large number, the value will be very, very large negatively, so that in the limit, you will have negative infinity. You can try like negative 1,000. That's a very, that's not that large, but can be considered as large. If you cube it, it will become even larger negatively. So you will have 5 times, what's negative 1,000 cubed? That's negative 1 billion. 5 times positive 5 kasi ito times negative 1 billion is very, very large. It's negative 5 billion. And so we can see right away that this will approach very large negative value, so that in the limit, as x approaches negative infinity, we have a negative infinity as a limit. So it's an infinite limit, and at the same time, it's a limit at infinity. Similarly, limit of 5x cubed as x approaches infinity, this is very obvious. When you cube a very large number, it will be very, very large. So in the limit, as x approaches infinity, in the limit, it is infinite. Is there any question before I continue? Let's look at the graph. You see from the graph that as x approaches very large values, your y values get very, very small until they almost become 0, so that in the limit, it's 0. Similarly, if x approaches negative infinity, the y values are getting very, very small negatively, so that in the limit, it's 0. And so this gives rise to what we call a horizontal asymptote. Okay, so let's first have some theorems that will allow us to evaluate limits at infinity efficiently. Consider, okay, the following. Here, k is a constant and n is an integer, a positive one. So that this one is dividing by a power of x, and this one is multiplying by a power of x. We have number one, limit as x approaches either positive or negative infinity, it doesn't matter. The limit of k over x to the n will always be 0. Take note of that, because the denominator is getting a very, very large, either positively or negatively. So you're dividing that constant by a very, very large number. So in the limit, it will be 0. Okay. Now, the second one, limit of kx to the n as x approaches positive or negative infinity equals either infinity or negative infinity. And that depends on, of course, the sign of k and the value of n, right? N could be even, n could be odd. So that if you're approaching negative infinity, okay, it will be negative infinity if odd, it will be positive infinity if even, and then that still depends on the sign of k, whether k is negative or positive. So let's see that. How do we use those two results or this theorem to evaluate the following limits? So here we have another, we have a limit at infinity. So limit as x approaches infinity of this cubic polynomial. So let's apply the following technique to evaluate that. Without using a calculator, okay, what we do is take out the, what we call this leading term, which is the term with the highest exponent. So the degree of this polynomial is 3. You take that, factor it out of the whole polynomial, as in here. If we do that, we will get this expression. So 2x cubed divided by 2x cubed is 1. Negative 10x squared divided by 2x cubed is negative 5 over x. X divided by 2x cubed is 1 over 2x squared. And then negative 100 divided by 2x cubed is negative 50 over x cubed. You can just verify those calculations. And once we do it that way, the expression inside the parentheses will just, some of the terms there will zero out, because there will be the presence of powers of x in the denominators of those terms, thus making them zero in the limit, as stated by this one here, the first part of the theorem that states if you divide a constant by a power of x, the limit will be zero at infinity, either way. So what happens here? This will be zero, this will be zero, this will be zero. Okay, after, of course, so there's really no need to do this, but after application of the properties of limits, remember product rule. So limit of a product equals the product of the limits. And then we evaluate each in product. Let's start with the second term here. We apply what we call another property, right? Sum and difference rule. Hindi ko na pinakita dito. So if you apply the limit, distribute the limit to each of the terms, you'll get limit of a constant is the constant. Limit of this, again, is 0. Limit of this is 0. Limit of this is 0. And then this becomes just 1. And then 1 is positive, and then you're approaching positive infinity. So the limit is an infinite one, positive infinity. And that should be clear from the first term of the polynomial. Actually, it's just the first term that determines the value of the limit, because it's the largest of all the terms. You're cubing here, you're only squaring here, and you have lesser powers here, so that if x approaches large values, what will determine, okay, the limit is the first term. In fact, we can see it from here. Okay, this becomes 1. And what is this? That's just the first term of the polynomial. And this term will always become 1 no matter what, because other terms will zero out. This will become 1. So 1 times the limit of this. And that depends, again, based on the second part. The limit is either negative or positive infinity, depending on n and, of course, the sign of k. So let's look at the same as x approaches negative infinity without showing you the details. As stated, the limit will depend on the first term. Okay. There's really no difference in the calculations, except that you will be replacing this positive infinity by negative infinity, but the calculations will essentially be the same. So replace this by negative infinity, replace this by negative infinity. So this will become negative infinity. Okay, why? Because when you cube negative infinity, it's negative. And then you multiply it by positive 2, so it's still negative infinity. Don't worry, you can just rewatch or, yes, this video asynchronously if you're confused, but we will have more illustrations so we can be familiar with the process. So let's generalize that result or that observation. How do you evaluate limits at infinity of polynomial functions? As stated a while ago, the limit of a polynomial like this is dependent only on the first term or leading term of the polynomial, which has the highest power. This is a polynomial function of degree n, and the limit at infinity will depend on this term. So limit of a sub n x to the n plus a sub n minus 1, coefficient yan, of x to the n minus 1, and so on and so forth until you have a linear term. There's a quadratic here, linear, constant term. That will be equal to the limit of a sub n x to the n as x approaches infinity or negative infinity. Let's apply that. Instead of having to go through these steps where you take out the leading term anyway, we will just use the leading term. So limit as x approaches negative infinity of negative 7x to the 5 plus x cubed minus 9x plus 12. And according to the theorem, that has the same limit as the leading term. So it's equal to the limit of negative 7x to the 5. Now, the value of this limit is infinite. Sign could be positive or negative depending on the sign here of negative 7, the index here or the power here, odd or even, and of course, what x is approaching could be positive or negative. So if x approaches negative infinity, what will happen to x to the 5? Will it approach positive or negative infinity? Negative, okay. Mr. Belen, Monares, negative, Roque, Cantosa, and Lanza. Okay, thank you very much. Kasi odd siya eh. Tapos ang negative number, erase mo sa odd, di ba? Negative pa rin siya. But here, this one is negative. So the final answer would be the negative of negative infinity. Tama? X to the 5 is approaching negative infinity. You're multiplying it by a negative. So the final answer is positive infinity. So ganun ka efficient yung theorem. Hindi mo na kailangan mag-factor out ng leading term. Ganun din naman. Ito ang matitira. So any question so far? By the way, bago ko makalimutan na, bukas na yung quiz, 3 points up. 3 questions, 10 points. Mag-start yon beginning of class. Pero may discussion tayo after. Kung may time pa, pwede kayo magtanong tungkol doon. So this time, let's consider rational functions. Their limits at infinity. Okay? So consider this one. It's a rational function. X approaches infinity. How do you go about calculating the value? So we apply the limit properties. Limit of a quotient equals quotient of the limits. So the numerator is the limit of a polynomial. So is the denominator. Then we apply the previous theorem. Only the leading term is counted or accounted for. So we have that. The limit of this polynomial is the same as the limit of the leading term. So with this one, leading term. And then we apply again the properties of limits in reverse. So this is a quotient of limits. So we will write it as limit of a quotient. Okay? Isang limit na lang, binaligtad lang natin yung pag-apply, pinagsama natin o nilagay na natin yung quotient nitong dalawa sa loob, isang limit na lang. Are we clear about that? And then, you see that you can cancel out the variables there. And so this will just become 1/3. And 1/3 does not change. It's always 1/3. So as x approaches infinity, the limit is 1/3. Limit of a constant is the constant. So we have evaluated the limit of infinity of a rational function fitly, and the answer is a finite limit. Now, what does this mean? There is a horizontal asymptote. And since the limit value is 1/3, that horizontal asymptote is y equals 1/3. And we use y because it's horizontal. If it's vertical, you use x equals. Now, let me just show you for a while. Hindi ko na kasi nasama sa PowerPoint presentation. Pero maganda, ma-familiar kayo sa paggamit ng GeoGebra. Who has used GeoGebra before in high school? Meron ba? Anyone? Ms. Monares, you can clarify your question at the end of class. Okay, I don't yet get what you mean. Now, look at this one. Okay, gagamit ako ng GeoGebra. I-share for this one. Okay, here is the app, GeoGebra. Ito, can you see the pointer, GeoGebra Classic? Yan, saan nagpo-point yung pointer. Yan, that's how the icon looks like of GeoGebra Classic. And once you've downloaded that, pwede mo siyang pag-aralan or hanap ka ng tutorial sa YouTube. Pero ito straightforward. Once you open it, you can just type in the function you want. So yung kanina natin, yung x cubed. Ayun. X cubed, 2x cubed. Let me type. So sa baba, you can see the makikita nyo naman dito itong screen na to. You click that and you type in, here's the x. You can see the x right here and the numbers here. You have the operations here, divided by, minus. So you type 2x cubed. So I'll type first divided by to avoid the confusion with the overall, okay, with just a divided by. So divided by, I'll go back. So let me type 2x cubed. Okay, here's the power, here's a square. 2x cubed, then down, because that is still it's an exponent, then minus 8x plus 13, then go down. Use the cursors here. And then type again 6x cubed. Already pre-graphing the parent function, but it's not yet complete. So 6x cubed plus x squared. I'll use the square operator here. And then minus 4. Oops, lumabas yung 4. Kaya nasa loob. Minus 4. That's the graph. Now I can zoom that in so we can have a clearer view, but let me just type the horizontal asymptote. According to our discussion, the horizontal asymptote, i-divide mo lang yung 2/6 actually. Mamaya tuturo natin yung shortcut. 2/6. So leading term by leading term. So y equals 1 divided by 3. Then press enter or this cursor here. You can see that. Then you enter na. Then wait for it, or you can click the screen if you want to really for the program to show it right away. There. That's the horizontal asymptote and it's clear. Yes, our calculations our calculation is correct. Now, you may question, sir, why did it cross the horizontal asymptote at the right-hand side? It's okay. Horizontal asymptote may or may not be crossed by the graph, but vertical asymptotes can never be crossed by the graph because you're dividing by zero there. Remember, how do you get the the vertical asymptotes? How do you get the vertical asymptotes of a rational function? You look for the zeros of the denominator, tama? So, ibig sabihin, hindi pwedeng ma-define yung function doon sa mga zeros. Kaya, yun ang dahilan bakit hindi pwedeng tawirin ng graph ang vertical. Kaya kapag tumawid sa vertical, alam mo nang may mali. But, pwede yung horizontal. In fact, pwede pa ngang several times, like 10 times, depende sa function. But, kailangan, as x approaches infinity, like here, kailangan asymptotic. Kung isasama pa, I'll teach you how to know where it will cross the horizontal asymptote. Parang hindi na yata masyado. Baka nga ang ibibigay lang yung hindi na tumatawid sa horizontal asymptote. So now let's go to how to find the horizontal asymptotes of a rational function. Let's consider another illustration. So let me repeat. Limit of 3x plus 2 over x squared plus x minus 1, x approaches infinity, positive. So leading terms na lang ang mahalaga. Hindi ko na nga dinaanan to. Dumiretso na ako dito eh. So I just retained the 3x, the leading term here, and below I retained the x squared, the leading term. And then I simplify. May matitirang x sa baba. That means it will zero out. Okay? Basta't may x na natira, positive or negative infinity, the limit is zero. Now, what is the horizontal asymptote now? Y equals 0, not 0, y equals 0. Tama. What is y equals 0? It's the what of the partition plane? The x-axis, yes. In other words, whenever the degree, pansinin nyo, dito kasi sa unang example, magkapantay sila ng degree. So that when you divide, itong mangyayari. If you retain the first terms, the variables or the variable will cancel out. No variable will be left, just a constant. And so you can get the horizontal asymptote by simply dividing the leading coefficients 2 and 6. But for this one, since the degree of the numerator is less than the degree of the denominator, a power of x will be left on the denominator. And so you will always get a 0. And thus, the x-axis will always be the horizontal asymptote. The equation, the line with the equation y equals 0. Now, what if the degree of the numerator is greater? Like in this one. As x approaches negative infinity of this rational function, dito, ano ang leading term? Hindi yung x ang leading term dahil lang nauna siyang sinulat. Yung pinakamalaking exponent. So, ang leading term mo ito, negative 3x to the 7. Okay, there. Correct. No horizontal asymptote. Okay. Now, x cubed plus 1, the leading term is x cubed. So, we will only retain those terms. Yan. Simplify. This time, a power of x will remain on the numerator. So, you know, the answer is an infinite limit. No longer finite as in the previous two. Dito, 1/3 finite limit. Dito, 0 finite limit. Pero dito, dahil mas malaki yung exponent ng numerator, hindi matitira sa numerator. which will make the limit infinite. In fact, negative infinity dahil even to. So dahil even siya, lagi siyang positive times a negative. So negative infinity. What does this mean? Correct. No horizontal asymptote. Okay, so let's generalize that. There. How do you find the horizontal asymptotes? In other words, you just have to compare the degrees. Case 1. If the degree of the numerator is less, automatically the x-axis or the line y equals 0 is the horizontal asymptote. There's always at most one horizontal asymptote. Hindi kagaya sa vertical, pwedeng marami, pwedeng wala. Pwede rin walang horizontal asymptote in case 3. Sa case 3, that happens, okay? This happens, no horizontal asymptote when the degree of the denominator, the degree of the numerator is greater. Typo error, okay? Paki-note yon. Degree of the numerator is greater. Now, if they have equal degrees, case 2 naman, they have equal degrees, you just divide the leading coefficients. Let's illustrate. There's no question. Let's find the horizontal asymptotes of those functions, of these functions. Number 1. Can you tell me what the horizontal asymptote of that is? Okay, no horizontal asymptote. Why? Case ano yan na lang? Case 3. Okay. Next. There. Okay. Okay, y equals 0, y equals 0. Case 1. Automatic na yon. Mas maliit yung degree, 2 dito, degree 2, degree 5. Automatic na yan. Wala nang computation na kailangan. Y equals 0. Next. Now, just be careful with your computation. So, ano ang leading term dito sa numerator? 4x to the 4th. So, kunin mo lang yung coefficient nun. Equal na sila ng degree, ha? Case 2 na tayo. So, take 4. And then dito, ito yung leading term. So, ito yung leading coefficient, negative 12. Just be careful. Simplify that to negative 1/3. Okay, is there any question? So, tomorrow we will have the quiz. And I think this should be enough for today. Hindi ko pa naturo kasi yung sign chart method. But the sign chart method will not be included for the quiz tomorrow. Didiscuss ko na lang yan bukas after the quiz. Puro break lang ng 5 minutes after ng quiz. Then we will proceed due to the lack of time pressure talaga. I could just actually, again, a reminder, leave what they call this, give you videos to study, and you do the study asynchronously, and then come class time, we just move on to the next topic. But for now, I think we need to have synchronous sessions every day. Lalo na mga basic pa to. No? Wala pa tayo sa masyadong computational. Papasok tayo sa computational pagdating na natin ng differentiation na mismo. Kung saan puro formulas na. And maybe doon, baka magkaroon tayo ng asynchronous classes na lang. Okay? Now, do you have any question regarding the quiz? Sir, when will you give out the exercises to prep us? No, hindi ako magbibigay ng exercises talaga. Pero sa midterms meron. Now, meron na doon sa meron na doon, hindi nyo pa na-check. Pakita ko ulit Pero yung mag-request ka ng meron na yung buong buo talaga wala eh. Pero per module meron. Share ko Punta ka doon sa, naka-student view naman sa modules. Sa modules natin, makikita nyo naman, halimbawa sa module 1 tayo. Ayan. Meron ng exercises dyan. Ayan. See this? This PDF file. Practice exercises for module 1. Click that. Nandun naman lahat sa canvas ng kakailanganin nyo as stated in the syllabus. Ayan. Now, pwede nyo i-consult na lang yan. Hindi ko yan mag-discuss kasi puro lesson muna tayo. Ayan. And then if you want the gist of the lecture, nandyan na rin, pinost ko na rin yung aking mga lecture notes. And then ito rin yung kadalasang i-discuss ko. Pero lang to kumbaga abridged version. Hindi lahat ng i-discuss ko sa online nandito. Saka hindi to wala masyadong explanation ito. Parang outline form siya. Yan, nandun siya. Yan o. Ito yung diniscuss natin ng mga nakaraan. Yung ngayon, nandito tayo. Yan, properties of limits. Yan, limit of a polynomial function. Tapos nandito na tayo. So kung gusto nyong masundan, yan, indeterminate forms. Yan. Continuity kahapon. Tapos nagdadagdag ako ng extra na mga exercises sa online na wala dito. Tapos ito tayo, yan, infinite limits. Now, itong sa module na ito, pag pinansin nyo, bukod sa lecture notes, yung mga pinrepair na modules last time or last semesters, pwede nyo ring aralin for detailed kasi ito eh. Halimbawa, yan nga. We have infinite limits. Click that. You want to study on that. There's a material given. At ito medyo very simple ang explanation kaya mas madaling intindihin kung gusto nyo mag-detail study. Yan. Now, yung lecture notes, yun yung mismong discussion. Hindi ito yung magiging discussion ko. So, kung gusto nyo lang naman, makakatulong tayo na may mga illustrations. Ayan. Idagdag nyo sa study nyo kasi mas maraming exercises dito. Tapos may practice exercises din doon. Yan ang maganda sa ating module. Kada section may practice exercises at maraming examples. Pero sa class, I will be following the lecture notes pero may added exercises. And then those in the book, kung gusto nyo ring sagutan, ayan, additional book exercises. Kailangan nyo laging kumbaga buting-tingin yung ating canvas para alam nyo kung ano yung mga pinopost ko. Kagaya dito, let's go to the home page. Ayan, makikita nyo naman yung to-do list. We have seat work, tapos na to, Feb 4. And then the new meeting passcode, binigay ko na. And then yan, quiz 1, 10 points, due 2:30 PM. Baka sabihin nyo, start ng 2:30, it's due. So click that just to be sure. Dahil lock pa, hindi nyo pa makikita. So there, it will be available Feb 10, 2 PM until 2:30 PM. Once you start answering, you have 30 minutes. And kung nag-start ka ng late, siyempre may minus na kung halimbawa late. Alam ko magko-close na rin pala kasi ng 2:30. So if you start late, halimbawa 2:05 ka nag-start, so 25 minutes na lang ang meron ka kasi automatic magko-close yung exam or quiz by 2:30. Unless lagyan ko to ng 2:50, so may 30 minutes ka, pero ang due time dito 2:30. So may minus, di ba, kada 5 minutes. Kada minute. So kung 5 minutes late ang submission mo, minus 5. So nandiyan naman as yan, syllabus. Yun lang naman importante. Tapos yung mga videos nandiyan na, yung mga nire-record ko yung videos natin. So kung gusto niyo makita yung reviewin yung discuss natin na yan, under that folder videos. So ito yung kahapon. Mamaya ipo-post ko dito yung ngayon. Ito yung lesson ko to last semester yata. 2 years ago na to. So start ng pandemic yun. Buburahin ko na yan mamaya. So pwede nyo na lang i-download. Kasi papalitan ko na to ng kumbaga fresh or dated na video sa limits at infinity, pero wala pa yung sign chart method. Any question? Are psi calculator allowed? Yes. Ganito re-remind ko kayo ulit. You can only answer one question at a time. Once you click submit, you can never go back to that. This is to avoid parang deterrent siya na magkaroon ng cheating kasi mas ma-absorb ka sa time na kailangan mong sagutan. And kasi nga, hindi naman sa sinasabi natin lahat, di ba? Pwedeng, di ba, may GC, yung ganitong mga group, and then doon lahat ilalagay. Pero marami kasing set to. Usually, at least 5 sets per question yan. Kaya mas mahirapan kayo. But hindi kayo required dito mag-Zoom. Hindi to live. Gagawin nyo to asynchronously. Pero yon, may time schedule namang sinusunod. Okay, so nasa sa inyo na yon. But pagdating ng departmental na midterms or long test pala, required na kayong mag-record ng screen ninyo sa Zoom. Pati yung table ninyo sa Zoom, kaya na yon. Both your work table or your working space and yung screen. Kayang gawin yan ni Zoom, di ba? Yung view yun eh. Ibibigay nyo yung link ng speaker view, pipiliin nyo lang yung speaker view na may gallery. Yes, after taking the quiz, may discussion pa tayo. Kasi baka mag-asynchronous tayo sometime next week. So, mag-Zoom kayo. Pwede rin namang mag-login na kayo agad sa Zoom while taking the quiz kahit naka-off lang yung camera. So, after ng quiz, sign chart tayo at kung may time, introduce natin yung derivative na. Any more question? So, hindi ko kayo na makikita, pero bawal talaga yung hindi scientific calculator, halimbawa graphing calculator, but then we leave it to your integrity. You will do it dishonestly. Mas maganda ang honest na mababa ang nakuha mo kaysa tumaas pero yung integrity wala, no? So sabi nga ng ano ba yun? ADAA ba nag-release na we leave it to your ang term na ginamit nila doon. Sabi na lang natin yung kasabihan na honesty pa rin is the best policy. Sa dami-dami ng mga policy na pwede nating ilagay to prevent cheating, still the best policy is be honest. Yes, bibigyan ko kayo ng passcode for the quiz. For this one, no passcode needed. No passcode needed. Kasi hindi nyo kailangan mag-login sa Zoom. Merong multiple choice, wala nang file upload solution doon. Either multiple choice or fill in the blanks. Ibibigay ko yung directions kung paano mag-type ng open interval, closed interval kung kinakailangan. Ewan ko, baka Math 21 yata yun. Basta follow the directions sa syntax kasi magpa-type kayo ng sagot nyo sa fill in the blanks. Pag hindi nyo sinunod yung syntax, ay mazi-zero, ima-mark tayo ni Canvas na 0. Meron pang tanong? Yes, wala na? You can email me or you can relay it, your question, okay, via the Beadle of the class. Is our Beadle here? Rashatan, you're here? Okay. So no more question. That's it for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.